Welcome to The Explainer. If you've ever felt that soul-crushing pain of writing endless boilerplate code in Java, well, you're definitely in the right place. Today, we're going to dive into a revolution in the language that really does turn those old frustrations into new superpowers.
All right, Ben, I've heard all the buzz about modern Java, but I'm still skeptical. I've written more getters, setters, and toString methods than I can possibly count. It seriously feels like I spend half my time writing code the compiler should just figure out on its own. So, go on. Convince me. What's really so different now?
See, this is exactly what I'm talking about. Just look at all that ceremony. 50 lines of code just to hold a person's name and their age. And it's not just that it's long. It's a minefield for typos and dumb mistakes. There has to be a better way. What's the modern answer to this whole mess?
I am so glad you asked. Okay, the answer is something called a Java record. And get this, that one single line of code you see there on the right, it does absolutely everything that those 50 lines on the left do. All of it. Just gone.
Records are just laser-focused on doing one job and doing it perfectly, being these simple, transparent, and unchangeable carriers for your data. But the real magic? The compiler writes all that boilerplate for you. The constructor, the accessors, equals, hashcode, toString, all of it is generated perfectly. Every single time. No more typos, no more forgotten fields. It just works.
Okay. I have to admit that's a massive improvement on the verbosity front, I'll give you that. But let's talk about a deeper and frankly a much more dangerous problem. How does modern Java stop developers from creating absolute chaos in the domain model? You know what I'm talking about. Someone creating some invalid state through uncontrolled inheritance and just breaking critical business rules.
That is a fantastic question, and it brings us right to the next piece of this power trio. So let's take a really common example, a payment status, right? It can be success, failure, or pending. Now, in the old Java world, what's to stop some new developer from coming along and creating their own, say, partially refunded state that our system has no idea how to handle? And that, right there, is how you get those dreaded 2 a.m. calls about bugs in production.
Modern Java's answer is something called sealed classes and interfaces. Just by adding that sealed keyword, you're basically creating a closed club of permitted types. You're telling the compiler in no uncertain terms, hey, a payment status can only ever be a success, a failure, or a pending. Period. Nobody can just waltz in and add a fourth state from outside this little hierarchy you've defined.
Okay, I do like that compile time check. I really do. But let's be real, the most dangerous bugs, the ones that keep us up at night, are the ones the compiler completely misses. So what happens when I'm writing logic to handle these states, but I just forget one? The code compiles and then everything blows up in production.
And this is where it all comes together. This is the climax. When you combine a sealed type with a modern switch statement that uses pattern matching, well, something truly amazing happens. You're about to see how we can just completely eliminate an entire class of runtime bugs.
If you forget to handle one of the permitted cases, let's say pending, for example, your code simply will not compile. It's a hard stop. The compiler is now fully aware of the entire sealed family, and it requires you to be exhaustive. This is a total game changer. What used to be a sneaky runtime bug that you discover at the worst possible time is now a compile time error that your IDE flags instantly.
So, now that we've seen the individual pieces, let's put them all together and see how they combine to build a completely safe and really expressive domain model. We'll start simple, with a sealed interface called shape.
Right, so we're defining our specific shapes as these immutable records, and because they're in the same file, they're automatically permitted as subtypes of shape. Got it.
Exactly. And then we write our business logic. And this switch right here is guaranteed, literally guaranteed by the compiler to handle every single possible shape we've defined. Now, if we go and add a triangle record later on, this code is dead on arrival. It won't compile until we come back and explicitly update it to handle a triangle.
And that right there is the modern Java power trio. You get these concise data carriers with records, you get controlled inheritance with sealed classes, and you get exhaustive compile time logic checking with pattern matching. They all just work together perfectly to let you model your domain with a level of safety and clarity that honestly just wasn't possible before.
Okay, this is genuinely impressive for modeling business logic. It really is. But, as a practical developer, I have to ask the question, can I finally throw out my huge verbose JPA entities and just replace them with these nice, clean records?
That is the million-dollar question, isn't it? And the short answer is, unfortunately,
No. And there's a really fundamental conflict here. See, records are immutable and final. That's their whole point. JPA, on the other hand, needs to be able to change an object state after it's been loaded from the database. It also creates these dynamic subclasses or proxies behind the scenes to handle things like lazy loading. And you just can't subclass a final record. They're at odds with each other.
So the key takeaway, the real bottom line, is to just use the right tool for the job. Records are absolutely perfect for DTOs and value objects. Sealed types are your go-to for modeling these closed domains, like state machines. And for your JPA entities, for now, you stick with your standard classes, maybe with a little help from Lombok or your IDE.
Okay, Ben, you got me. I'm convinced. This is a fundamentally safer and way more expressive way to write Java. It actually solves real-world problems that I've personally been wrestling with for years.
Exactly. It's a fundamental shift in how we write safe code. We're literally moving the responsibility for catching entire categories of bugs away from our test suites, away from our production logs, and putting it right where it belongs, inside the compiler. So the real question to leave you with is, with this new compiler safety net, what impossible bugs are you going to prevent in your own applications?